आज जो हमारा टॉपिक है उसका नाम है इक्वेशन ऑफ लाइन सॉरी इक्वेशन ऑफ प्लेन वी विल बी टॉकिंग अबाउट इक्वेशन ऑफ प्लेन ओके so our topic of today is equation of plane. Plane in real geometrical sense, the plane has length and breadth, but it has no thickness. Okay, plane has line has plane has length and breadth, and it has no thickness. So we move on and we start doing it. And our plane is infinite. It does not have any limits. Okay. Now, what is the common feature that can be attached to a plane? For example, in the case of O level, a line used to have a gradient. That gradient used to be a common feature that for a unit change in xy goes up by 2, then again for a unit change in xy goes up by 2. This was a consistent fact throughout the line, okay? But in 3D, we used to have a direction vector. The full line was parallel to this direction vector. And if we choose any 2 points randomly on the line, the vector AB is parallel to this direction vector. So similarly, can you think of anything which is common to the whole plane, which is common to all vectors? For example, this vector V1, this vector V2, and then with this vector V3, V4, all what you can say is something which is common to all these vectors. What is the feature of this plane that will stay constant? Like, that the gradient in the case of a 2D and a direction vector in the case of 3D. Is there anything which can stay constant for a plane and which is same for all these vectors V1, V2, V3, no matter in which direction they all lie? For example, this is the plane.
सर इनकी नॉर्मल जो होगा वो सबका सेम होगा.
जी बिल्कुल, you're right. For example, this is vector V1 and this is vector V2, this is vector V3, this is V4, this is V5, this is V6, V7, V8, V9. Okay, so that means the vector perpendicular to the plane will be perpendicular to all these vectors V1, V2, V3, V4. So if we want to know the equation of a plane, the common feature of the whole plane is the vector normal to the plane. And this vector normal will be perpendicular to all the vectors in the plane, okay? So if there are vectors V1, V2, V3, V4 lying in the plane, n will be perpendicular to all of them, and the dot product of V1 with n will be 0, the dot product of V2 with n will be 0, the dot product of V3 with n will be equal to 0, and the dot product of all the vectors with this vector n will be equal to 0. And this vector n can have any length. Okay, so that means we just need a vector perpendicular to the plane in order to find an equation of a plane. But that vector normal to the plane, can have any length. So that means we are not interested in the length of this vector. All we need a vector perpendicular to the plane. Even if it is just a unit vector, it has a magnitude of 1. It can have magnitude of any length. Okay, so in order to find the equation of the plane, you need to know a vector perpendicular to the plane. Let's call it 3i plus 4j. Let's consider, for example, that this is 3i plus 4j plus 5k. It's a vector perpendicular to the plane. And then, like in O level, we needed gradient of the line and the point on the line in order to find the equation of the line. Similarly, we need at least one point on the plane to find the equation of the plane. Okay. Now consider point P. P is a general point lying in the plane. Okay. And AP is a vector which lies in the plane. No matter wherever P moves in the plane, within this plane, AP will remain in the plane and AP will be perpendicular to N, or N will be perpendicular to P, AAP. Okay. Now AP is equal to OP minus OA. OP XYZ minus 1 to 5. This is equal to x minus 1, y minus 2, z minus 5. This is AP. Now, wherever P moves, AP remains within the plane, and the dot product of AP with N will be equal to 0. The dot product of AP with N will be equal to 0. Okay. So if we calculate the dot product of AP, the dot product is equal to 0. So this becomes, so if you calculate this dot product stepwise, you arrive at this. And this thing becomes equal to 36. So this is the equation of plane. This is called Cartesian equation of plane. This is called Cartesian equation of plane. This is called Cartesian equation of plane. So in order to find the equation of plane, you need a vector perpendicular to the plane, and you need a point on the plane, a fixed point on the plane. And then you suppose a general point on the plane, Pxy. And you know, wherever P moves within the plane, AP remains in the plane, and AP will always be perpendicular to N. And as a result, if we calculate their dot product, the dot product will always be 0. So this gives you the Cartesian equation of a vector, a Cartesian equation of the plane. And you should note this, down, that the components of vector normal appear as the coefficients of the equation of the plane. You should note down that 3i plus 4j plus 5k, 3, 4, 5 were the components of vector normal to the plane. They appear as the coefficient of xyz in the equation of plane. So this is how it is. This is how you calculate the equation of a plane. I give another example. I quote another example. For example, find the equation of plane whose vector normal is is 11i plus 13j plus 17k, and it passes through 1, 1, 1. Okay. Find the equation of plane whose vector normal is 11i plus 13j plus 17k, and it passes through 1, 1, 1. Now, the vector normal to the plane is shown like this. I show it with the help of a thick vector. We call it n, and n is 11i plus 13j plus 17k. We can also write it as 11, 13, 17. And then we suppose a point, we show a point. We do not suppose it's given. A is given to us that the plane passes through this point or the plane contains this point. Let us suppose a general point P, X, Y, Z on the plane. AP is a plane AP is a vector which always lies on the plane. AP is a vector which lies on the plane, and the dot AP is always perpendicular to n. No matter wherever P moves in the plane, AP is always perpendicular to the n, and the dot product of n and AP is always equal to 0. Okay. Now we calculate AP. AP is OP minus OA. And OP is XYZ. OA is 1, 1, 1. And this is equal to X minus 1, Y minus 1, Z minus 1. And the dot product of AP dot N is equal to 0. X minus 1, Y minus 1, Z minus 1, dot 11, 13, 17 equal to 0. This is 11 into X minus 1 plus 13 into Y minus 1 plus 17 into Z minus 1. And when we simplify this, it is equal to 41. So, and you should note this down that 11 is appearing over here, 13 is appearing over here, and 17 is appearing over here. So this is how you find the equation of the plane. So whenever they ask you to find the equation of the plane, you should ask two questions. Number one, that do I have a point lying in the plane, or a point, do I have a coordinates of at least one point lying in the plane? And do I have the values of the vector normal to the plane? I just need a vector normal to the plane, perpendicular to the plane, whatever is its magnitude. I just need a vector perpendicular to the plane. These are the only two things that you need to find the Cartesian equation of a plane. A plane is a two-dimensional object according to the standard mathematics. It has length, infinite length, it has infinite width, and it has zero thickness. Okay. Although that this is a theoretical concept, but still it is a very useful concept. Okay. Now, a shortcut of finding the equation of plane. This is called Cartesian equation of plane. So the general format is ax plus by plus cz is equal to d. This is Cartesian equation of a 2D plane. Equation of a plane. And as we know that y is equal to mx plus c is a equation of line, and y is equal to mx is a line specifically passing through origin. Similarly, if d is 0, then ax plus by plus cz is equal to 0 is an equation of plane which contains origin. Plane containing origin. 0, 0, 0. Okay. And as we know,
इसका क्या मतलब है? Plane containing origin का मतलब?
Means the plane which passes through this point 0, 0, 0. A plane which has a plane is a plane which passes through origin, or which contains origin, or the point where x and y and z axis intersect. That point is also contained on the plane. Okay. And as we know that y is equal to k or x is equal to k are the lines which are parallel to x and y axis respectively. Similarly, x is equal to 0 is the equation of yz plane. X is equal to 0 is the equation of yz plane, and y is equal to 0 is the equation of xy plane, and z is equal to 0 is the equation of, sorry, this is
सर वो
x,
ऊपर x z प्लेन नहीं होगा?
no, yz plane. When x is 0, it's a yz plane which contains y-axis and z-axis. Okay, and y is equal to 0 is xz plane which contains x-axis and z-axis, and z is equal to 0 is xy plane, and x is equal to 2 is a plane which is parallel to yz plane, is a plane which is parallel to yz plane, and it is parallel to the plane which whose equation is x equal to 0. Similarly, y is equal to k is a plane which is parallel to xz plane, and similarly z is equal to some k constant is a plane which is parallel to xy plane. So these are some simple equations which represent planes, very common planes which are often encountered in the fields of engineering. Okay, now if they ask you to find the equation of plane which passes through the following 3 points, let's say that they give us 3 points lying on the plane, and they do not give us vector perpendicular to the plane. For example, they give us a point A241, then B 30 minus 1, and then point C 8, 1, 1. Okay, you know, in O level, if they do not give you gradient to find the equation of line, then they used to give you at least 2 points on the line, and with the help of those 2 points you were able to find the gradient yourself. And then once you have found the gradient, you could have used any one of the point. We could use any one of the point and find the equation of the line. But over here, if they do not give us the vector normal to the plane, then they must give us at least 3 points which are not collinear. They should give us 3 points on the plane which should not be collinear. That means B, A, and C should not be lying in a perfect straight line. Okay.
सर वो कोलिनियर इसलिए नहीं होने चाहिए क्योंकि उनका क्रॉस प्रोडक्ट 0 होगा, अगर हम निकालेंगे तो परपेंडिकुलर आ ही नहीं सकता।
जी बिल्कुल, you are right. It will be impossible to calculate their vector normal. Rather, there will be infinite possibilities of their vector normal. Okay, so we calculate AB and AC and calculate the cross product of AB and AC. So vector normal is, we can calculate the vector normal, a vector perpendicular to the plane. Vector normal to the plane can be calculated. Vector normal to the plane can be calculated by taking the cross product of AB and AC. You know, AC lies in the plane, AB lies in the plane, and their cross product will give us a vector perpendicular to the plane which contains AC and AB. Not only we can use this thing, we can also use, it's not mandatory that we should use AC and AB. We can use BC and BA to find that vector normal, and we can also use CB and CA. We can use CB and CA to calculate the vector normal, and there is no compulsion of order as well. We can calculate AC cross AB or AB cross AB. We should not worry about the order. We can calculate BC cross BA or even BA cross BC, or CA cross CB. So that means we have 6 different possibilities of calculating vector normal. Okay, now let's start. This is A. The vector A is 2, 4, 1. The vector B is 3, 0, -1. And the vector C is 8, 1, 1. Okay. Now consider this is a plane which contains these 3 vectors, A over here, B over here, and C over here. We first of all calculate AB. AB is equal to OB minus OA. We should memorize that the position vector of B is written first and then A is written later on, and the position vector of B is subtracted from position vector of A. This is vector AB. Now we calculate AC. AC is OC minus OA. It's A 811 and OA is 241. This is equal to 6 minus 30. Now I have AB and AC and I should use them to find their cross product. Okay. I should write them adjacent to each other so that I can easily calculate AB cross AC. AB cross AC, once I told you, as the name suggests, cross product. The cross product is cross from AC and AB. It doesn't want to lie in the plane which contains AB and AC, and hence N is perpendicular to the plane which contains AB and AC. So AB cross AC is a vector perpendicular to the plane containing AB and AC. So now we start applying our formula of calculating the cross product. Now if we simplify it, it is this becomes equal to -6, 12, and 21. This is the vector normal. This is the vector normal to the plane. And as I told you, that we need a vector normal to the plane. We need a vector normal to the plane, no matter whatever is its length. So we have the right to simplify or divide the vector normal by any other number so that we can get smaller numbers. For example, in this case, I would like to divide the whole vector normal by 3. That will give me some simpler numbers. I just need a vector perpendicular to the plane. I'm not interested in the magnitude of this number. I'm not interested in the length of this vector. N can have any length. All I need is that it should be perpendicular to the plane containing A, B, and C. So if I calculate a vector N by cross product and say that the numbers appear to be the multiple of some common number, I can divide them by that number to simplify my number. However, I cannot do so with any point. For example, if they say that the point 100, 200, 300 lies in the plane, I cannot simplify it like this. I have no right to simplify the coordinates of a point, but I can simplify the vector normal. I can divide it by some number. I can multiply it with some number. I can put a negative, I can multiply it with -1 to remove the larger number of negative sign. For example, if my vector normal is like this, I would rather like to have A negative and B and C positive. I will multiply it with -1. I can do so. This is not going to affect my calculations. Okay. Now for this particular plane, I have calculated the vector normal, which is equal to -247, and then A is 2 4, A is 2 4 1. I can use A, I can use B as well, and I can use C as well. I can use any of them along with this vector normal to find the equation of the Cartesian equation of the two-dimensional plane. Okay, let's suppose a general point. Let's suppose a general point P, X, Y, Z, and let's calculate our AP. Okay, I redraw this vector again for you, and I only draw point A, which is 2 4 1, and then a general point P, X, Y, Z, and AP is a vector which is lying in the plane, and N is a vector perpendicular to the plane, -2 4 7. Now AP is equal to OP minus OA. This is equal to XYZ -2 4 1. It is equal to X minus 2, Y minus 4, and Z minus 1. Okay. And now AP dot N is equal to 0. When we simplify it, it is this thing. -2x plus 4 plus 4y minus 16 plus 7z minus 7 is equal to 0. -2x plus 4y plus 7z is equal to 16 plus 7 minus 4, and 2x minus 4y minus 7z is equal to 19. So this is the Cartesian equation of two-dimensional plane. Is there any question that you would like to ask? I'm here to answer. Hello. But is there any question that you like to ask? I'm here to answer, beta. जी बेटा. जी. Okay. We move ahead. Okay. A short method of finding the vector, a Cartesian equation of plane. Shorter method. Of finding. I'm listening.
सर ये आपने जो वो क्या कहते हैं, हम इसको AP की जगह हम कोई भी पॉइंट के साथ वो नॉर्मल वेक्टर को डॉट प्रोडक्ट नहीं ले सकते और फिर उसको डायरेक्ट D की जगह पे रिप्लेस कर दें?
Say it again. I am listening to you. Please दोबारा कहें आपने क्या कहा?
सर AP के बजाय हम कोई भी पॉइंट ABC का डॉट प्रोडक्ट ले लें नॉर्मल वेक्टर के साथ.
We can do BP dot n is equal to 0. We can do CP dot n is equal to 0. We can even do PA dot n is equal to 0, or PB dot n is equal to 0, or even PC dot n is equal to 0. They'll always give me the same equation. Two-dimensional vector equation of a plane is a unique equation. If you do use any method, you'll arrive at the same equation. And now we move on to the shorter method of finding the equation of plane. Many teachers teach this method. This is a very short method, and you can write the equation of plane in one step, okay? But before that, I move on to this topic. Again, consider this plane. This is the vector normal to the plane, and point A is a fixed point on the plane. P is a variable point on the plane, which can wander everywhere inside the plane, okay? And as P moves inside the plane, AP can have any length, can have any direction, but AP will always remain in the plane, and the dot product of AP with N will always be equal to 0. Now AP dot N is equal to 0. You know that we can write AP as OP minus OA. We can write AP as OP minus OA dot product with N, okay, equal to 0. So OP dot N minus OA dot N. You know that dot product is distributive. You can open bracket and can take their dot products individually. Now OP dot N is equal to OA dot N. So this is the method that I want you to apply. This is the very short method, okay? I do the question with the help of this method, okay? The notation might seem little problematic, but its application is extremely simple. For example, a plane contains 0.378 and a vector normal to the plane is, say, 5i plus 2j plus 7k, okay? If they ask me to find the equation of the plane, what I will do is that I will write x, y, z dot 5 to 7 and then 378 dot 5 to 7. And then I will write 5x plus 2y plus 7z is equal to 3 into 5 plus 7 into 2 plus 7 into 8, which is equal to 5x plus 2y plus 7z plus 7z. And the number on the right hand side becomes 29 added with 56. It's 85, I think. So this is the Cartesian equation of the plane. You can even omit this second step. You can directly, by looking at this thing, you can directly write this, and then you arrive at this equation. You can even omit this step as well. Okay. So this is the shortcut by which you can write the equation of plane. You know that this 5 directly comes with x, this 2 directly comes with y, and this 7 is directly written as the coefficient of z. Okay. And then you have to multiply 3 with 5, 7 with 2, 8 with 7, add them up and write down on the right hand side. So this is a very simplified approach of finding the equation of the plane. I illustrate the same method by another numerical example. If they give me um, a vector normal 5, 2, 3, and then 5, instead of 5 over here, I can say 11 minus 2, 7, and then 1, 1, 2 point lying on the plane. I will directly write its equation. It's 11x minus 2y plus 7z. And it is equal to this 11 multiplied to this one, this minus 2 multiplied to this one, this 7 multiplied to 2. It is 11 into 1 minus 2 into 1 plus 7 into 2. So it's 11x minus 2y plus 7z is equal to 14, 11, 25 minus 2, 23. So this is how we can find the equation of the plane. We can express the equation of plane in variety of variety of ways. For example, you know, when we were doing this, applying this formula of AP minus, when we were applying this formula, that A is a fixed point on the plane, P is a variable point on the plane, and the coordinates of P are X, Y, Z, and this is vector normal. For example, vector normal is 2I minus 9J plus 17K. And let's say that the point point A is 2 minus 2, 1 minus 3. Okay. Okay. I know that AP dot N is equal to 0. And I know that OP minus OA dot N is equal to 0. Dot product is distributive. I can open the brackets and can multiply, can take the dot product with the individual vectors. I can write this OP as R and can write N as this, keeping it, you know, its IJK intact. And over here on at A OA dot N, I will multiply them directly. I will not show any mercy. Over here, minus 4, minus 9, and minus 51. R dot 2I minus 9J plus 17K is equal to what? Minus 64. So this is also vector equation of the plane. And then I can write it like this as well. You will see even the equations of the plane written in this style. So these all styles are famous and often written like, I will often find them written like this. Okay. Is there any question? But if you want to ask any question. Hello. Ji.
No, sir.